As you can see, method listenForContact, which we mentioned in the previous video, simply creates an object of our nested class receiveContact task, which we'll look at down here in just a moment, and executes that task. Now, the receiveContact task is going to set up a socket for listening for connections, and then it's going to receive a contact if a connection is received from a remote device. So as you can see here, we're extending async tasks so we can perform this task in the background in a separate thread. And that's important once again because we don't want to do any kind of input-output in the main GUI thread, as it could lead to the GUI locking up and our apps getting terminated by the operating system. So you can see that this nested class has a couple of instance variables. We have a Bluetooth server socket, which we will be getting back from the Bluetooth adapter when we register this app with the Service Discovery Protocol server so that remote devices can connect to it. And then separately, we have a Bluetooth socket at line 251 here, which once a connection is received, we will get back and then be able to perform the communication. In our doInBackground method, which is going to perform the task in the background, we start with lines 260 through 262, where we call the Bluetooth adapter objects listen using rfcom with service record method. And we give it two arguments, the string called name and the UUID called myUUID that we declared back at the beginning of the AddressBook class. And what this method is going to do is register this app with the Service Discovery Protocol server, the SDP server, putting this key value pair of name and UUID into the server so that remote clients can then connect and look up what communications channel should be used for communicating with this app on the current device that's running this code. We then display a toast via the handler indicating that we're waiting to connect, and the return value from that method, by the way, is a Bluetooth server socket. So we store that and then use that down here at line 268 to accept a connection from another device. Now at this point, this thread in the background blocks and waits for a connection. If a connection is received, we get back a Bluetooth socket object, otherwise an exception could potentially occur. But assuming we get a Bluetooth socket object, we now have the object that we need to obtain the input and output streams for reading and writing data over the connection. Now in this particular app, we only get the input stream here at line 271 because the remote device is sending a contact and this device is simply receiving it. I suppose we could also send a message back to the remote device once we do receive it, just as a confirmation. But in this case, we just got the input stream for reading bytes from the other device. And also in this case, we're going to read the bytes into a 1024 byte buffer, and the integer called bytes will represent the number of bytes that we've read. And at line 278, we read the contact's information from the other device, which is sent over as a stream of bytes, into the buffer that's specified as an argument here at line 278, and the variable bytes is assigned how many bytes were read. Now, in reality, it's possible that whatever gets sent from the remote device will not completely get sent in one operation. So what we really should be doing here at line 278 is some sort of a loop that keeps reading bytes until the value -1 is returned from the read method to indicate that there's nothing more to read, and then using that result, which we would presumably assemble into a larger buffer, as the foundation for the JSON object that we're going to be creating momentarily. Now in our case, the number of bytes being transferred is so small that we decided to just read once and assume all the bytes were read from the remote device, although that is possibly not going to work if there were more data sent across. Now, under the assumption that bytes is not equal to -1, which would indicate that we really did read something, we declare a local database connector variable, which we'll be using in a moment to communicate with the database. And then in a nested try block here, we create a JSON object called contact, and it's a new JSON object that's going to be formed from the string That's the result of this highlighted part here on line 289. And basically we're going to use the full buffer, to create this new string, and then as you'll see, as you're seeing here, JSON object has a constructor that receives a JSON formatted string, and it uses that to create a JSON object consisting of, in our case, the values that represent the fields in the database for our address book app. Now, we at line 292 and 293, assuming that we correctly form the JSON object, next create an object of our database connector class. We open the database, and this is the same stuff as we did back in lesson 10. And then we call our database connector objects insertContact method, and what we're going to insert are the name, email address, phone number, street address, and city, remember, represents the city, state, and zip code in this app. So each call to get string on the contact object looks up the key that's specified as an argument and gives back the corresponding string value in this case. And there's other get methods for class JSON object as well. Now, once we've inserted the contact, we go ahead and create a new get contacts task, which is going to update the list view in our address book. We also display a toast indicating that the contact was received. If we get any exceptions along the way, we'll display a toast, and you can see here that we're closing the database connector in the finally block, and then we return back to the outer try-catch sequence, and you can see in the finally block for the outer sequence that we also close our server socket and the Bluetooth socket object as well to terminate the communication.